Hello everyone, welcome to this video. In this video, we will walk you through our project on emotion classification using KNIME. This project involves classifying text into positive or negative emotion using a machine learning approach. Throughout this video, we will cover the following key areas. The objective of the project, methodology and KNIME workflow, the results and insights, and final conclusion. The primary goal of this project is to classify text into positive or negative emotions using machine learning techniques. Emotion classification is widely used in applications such as social media monitoring, sentiment analysis for businesses, customer feedback evaluation. To achieve this, we have used the KNIME Analytics platform, which is a powerful no-code, low-code tool for data science and machine learning. It has allowed us to pre-process textual data, extract meaningful features, train and evaluate a machine learning model. Now let's take a look at the actual implementation. For the purpose of our project, we've used a data set imported from Kaggle, which has 2000 records of label data of positive and negative emotions. For example, if we see here the sentence, I find myself in the odd position of feeling supportive of, has been labeled as a positive emotion. Looking at the workflow, we have begun by importing our data using a CSV reader. The dataset consists of textual data as well as a label associated with it. To make the text useful for the machine learning, we converted it into a structured document format using the document creation node, which has, when we open the meta node, has a row filter, strings to document converter, which converts the strings into a document format, and the column filter. Later, we have the enrichment node, in which we've used a POS tagger to tag the individual words of the document with its parts of speech. This helps us identify keywords and grammatical structures, which makes it easier for the model to predict the patterns. Later, in the pre-processing stage, when we look into the meta node, we have used a number filter which filters out all the numerical elements present in the text. And then we've used a punctuation eraser to get rid of all the exclamation marks, commas, and all the other special characters. Later, we have used a stop word filter to filter out all the stop words, and then we've converted all the text into a single case. And then we've used the snowball stemmer to convert all the words into their base form. For example, here you can see the word confused has been converted into confused as its base form. Later, we've used a tag word filter where we've filtered out only adjectives, nouns, proper nouns, etc., and we've gotten rid of all the other tagged words. Moving on, we have the transformation. Since machine learning models do not understand text directly, we convert the clean text into numerical representation using the bag of words node and the term frequency node. Here we can see that in row 1, we have the word didn't with a relative term frequency of 0.333. In the similar fashion, all the other terms have been calculated for their relative term frequency. Once the transformation has been done, we've applied this, we've used this training data to create our model. We run the decision, for this purpose, we've used the decision tree learner. And once we run the decision tree learner, we get the decision tree generated. Let's now look into the decision tree generated. At the base level, we are categorizing the sentences based on the word passion, where you can see when the word frequency of passion is less than zero point 0.5, it has classified the word sentence as a negative emotion tagged sentence. Whereas when the frequency of the word is greater than zero point 0.5, it has classified as a positive emotion sentence. We can expand the decision tree to look at the various stages of classification that has been occurring here. Like in the second stage, the sentences have been classified based on the word happy. In the third, we can see that it is bless and also rush. In a similar fashion, when we expand the decision tree, we can find out the various words that are used to split and make a decision of positive and negative emotion. Once the model has been generated, we have used a testing data set with predefined labels. Like you can see here, we have the text and the corresponding label. We have uh, used document creation node to convert this data into a document format which can be used in further pre-processed. We've used enrichment again and then pre-processing and cleaning of data where we've removed the tags, stop words, punctuation marks, and numerical filters. And then later on, we've converted this into a numeric format using the bag of words and term frequency and document vector applier. Once all the pre-processing and cleaning has been done, we have fed this training data to our decision tree predictor. When we run the decision tree predictor, we can find that the model has predicted the labels for the training testing data set. Here, when you see the first row, we have the text document abandoned millionth time life span. This sentence has been originally classified as a negative emotion statement, and the predictor has correctly predicted it as a negative emotion. Whereas when you look at uh, the statement in row 2, we see that it has been originally classified as a negative emotion, whereas the predicted has predicted it as positive. To find out, like, we can go further and check for where and all there has been a wrong classification, but this is a very manual tedious job, so we've used the scorer node to evaluate the model's performance. This provides key evaluation metrics like accuracy and error. Let me just run the scorer node, and here we have the result. Let's analyze the confusion matrix the scorer node has generated. The true positives, that is correctly predicting the true positive emotions. We have 424 correctly predicted instances of negative negatives, and then we have positive positives, which are 428 instances, and then we have false positive and false negatives, that is incorrectly classifying negative text as positive and positive text as negative, where we have uh, 71 and 74 instances of it. Overall, the model has achieved an accuracy of 85.456%, which specifies that the model is accurately able to predict 85% of the instances rightly. And we have an error percentage of 14.54%, which indicates that the model is making an error for 14.5% of the instances. To conclude our project, these are the results that we've obtained, which specify that our model is quite promising. However, more uh, more textual pre-processing can be done for improving our model. In conclusion, the project has successfully demonstrated emotion classification using KNIME. We built a workflow that pre-processes text, extracts features, and applies machine learning to classify emotion. Thank you. This is our whole workflow. Thank you.